This is going to straight follow from yesterday. It's basically the same thing as yesterday, but instead of 0 equals, we're going to have y equals. So this says, write the quadratic function in intercept form and give the functions zeros. What you need to remember, intercept form looks like this, which basically, it's got two sets of parentheses. It's factored. Intercept form is the same as factored form. The functions zeros, solutions, and x-intercepts are both words that mean the function's zeros. So whether you call it the function's solutions, the function's x-intercepts, the function's zeros, it's all the same thing. So yesterday, you got one side equal to 0, you factored, and you solved. Today, we are going to have one side equal to y, factor the other side, and then find the intercepts, which is the same as solving. So, number 8, we need to factor x squared minus 3x minus 40. We're looking for two numbers that multiply to give us negative 40 and add up to negative 3. At this point, you should feel fairly confident with this type of factoring. If you still don't feel confident with factoring when your a value is 1, when there's a 1 in front of your x squared, you should come in during Wildcat Hour and get a little bit of help from me. Some one-on-one help with factoring, and I promise you will feel more confident than you did when you walked in. So do not be afraid to walk in during Wildcat Hour A when I'm in here and say, hey, can you help me with factoring really quick? And I'll help you for like 3 minutes, and then you'll feel better, I promise. Okay, these numbers would be 5 and negative 8. So the factored form would be x plus 5, x minus 8. Just don't forget that there was a y equals in front of that. To solve this, to find the zeros, think about what number does x need to be to make this first set of parentheses equal 0. X would need to be negative 5. You can think of it that way, or think of it as take the opposite of whatever number is in there. So negative 8, our solution would be positive 8. So your zeros, your solutions, your x-intercepts are negative 5 and 8. And just keep in mind, that means that if you were to graph this parabola, it would cross the x-axis at negative 5 and at positive 8. Okay, number 9. I'm going to talk to you about being strategically lazy. You could multiply 3 times negative 15 and look for two numbers that multiply to give you negative 45 and add up to negative 12. But wouldn't it be easier if there wasn't a number in front of your x squared? So think about, do these 3 terms, could I divide these 3 terms by 3? Yes, we could. So we have y equals 3 parentheses. 3x squared divided by 3 is x squared. Negative 12x divided by 3 is negative 4x, and negative 15 divided by 3 is negative 5. Isn't the stuff inside those parentheses a whole lot easier to factor than what we had originally? So we're looking for two numbers that multiply to give us negative 5 and add up to negative 4. Well, it has to be 1 and 5 somehow, because that's the only way you can multiply to get 5. Looks like the 5 needs to be negative. So the factored form is x plus 1, x minus 5. Don't forget, there's a 3 in front of those parentheses, and there's an equals y. Okay, intercept form. Find the zeros. What are the zeros? Negative 1, positive 5. Okay, now what if you, this is kind of from yesterday since I wasn't here to help you with it. What if you had a problem that factored to look like this? The second set of parentheses, those are pretty easy to solve. What number plus 2 would give you 0? -2. How about this first set of parentheses? You would have to go over to the side and do 2x plus 3 equals 0 and solve to figure out what that x is. You'd subtract 3 on both sides, and then you divide both sides by 2, and you'd get x equals -3/2. Would you like a shortcut so you don't have to do all that work every time? Okay, take a look at the parentheses. What's the opposite of +3? And then put the 2 in front of the x underneath it, -3/2. It's basically the same as solving. You're subtracting 3 on both sides to make it 2x equals -3, so opposite of that 3, and then divide it by whatever's in front of the x. So that's just the quick way that you can get to that solution without actually having to show the work. We're going to do number 1 on this worksheet together. A student environmental group wants to build an ecology garden as shown. The area of the garden should be 800 square feet to accommodate all the species of plants the group wants to grow. What should the dimensions be? All right, step 1, it's talking about area. Area equals, how do you find area? Length times width. So we've got x times 60 minus x. Our first step is going to be, I actually wrote this 1 in the wrong place. Our first step is going to be to multiply this out. So we've got 800 equals, if we distribute, we'll have 60x minus x squared. Now, this is a problem like you had yesterday. So, you want to get one side equal to 0, but x squared needs to be positive. So, it would seem easiest to subtract 800 on both sides, and then you'd have 0 equals, but that would leave that x squared as a negative, and we don't want that. So we need to add x squared to both sides. So if we add x squared here, we'll get rid of it. Add x squared on the left. We also need to subtract 60x from both sides. And we still have that plus 800. Oops, I ran out of room. Does this now look like something that you know how to factor? Yes. So your third step is going to be to factor and solve. You're looking for two numbers that multiply to give you 800 and add up to -60. Since we're multiplying to get a positive number and adding to a negative, that means they're probably both going to be negative. So think about what times what would give you 800 but add up to 60. So 1 times 800, no. 2 times 400, no. We're not even close. Think more like 10 times 80. Does 10 times 80 work? What would you think of next? 20 times 40, would that work? -20 and -40. So the factored form is x minus 20, x minus 40. So our solutions are +20 and +40. Okay. So they're asking what are the dimensions of this garden. So take those numbers and plug them in. If we plug 20 in, that would make this side be 20 feet. And if we plug 20 in up here, 60 minus 20 is 40 feet. If we were to plug 40 in instead, we'd have 40 feet, and then 60 minus 40 is 20. So, I mean, it's going to be the same dimensions no matter what. Ultimately, this rectangular garden is 20 feet by 40 feet. So we're done with this first part. I'm going to let you do the second part on your own. A local construction company has donated 120 feet of iron fencing to enclose the garden. So think perimeter. Now that you know the dimensions, if you have 120 feet of fencing, is that enough to put around the pool or not? As you finish this worksheet, you get to skip number 3. I would like you to do number 2. It's a slightly smaller version of what we just did. 4, 5, and 6 at the bottom of the page, you can pick 2 out of the 3 to complete. On the back side, 7 through 9, pick 2 out of the 3. And 10 through 12, pick 2 out of the 3. You can attempt the bonus problem at the bottom if you would like.